Okay, so today's the last section of, or the last part of chapter 10. So tomorrow you guys are going to have a short quiz. It's 10 questions. It'll be on Canvas. 20 points. Anyway, there will be a little bit of this in there tomorrow, but kind of just simpler problems. What we've been doing this week is, for the most part, I think been pretty simple, and today, like, totally ramps up, and today is so fun! Which usually, in terms of, like, risky language means it's a little tricky.
It's fun.
It is fun. I think you guys will like it. So, what we're talking about today, similar to what we did yesterday. So yesterday we talked about how to find the area of a sector. Remember, a sector, it's like a chunk of a circle. If you were to take out a slice of the pie, that would be a sector. Okay? What we're going to do today is we are going to take that sector and we're going to connect the endpoints that are on the edge of the circle. And if you do that, and if you take out that middle part and you just look at that outside part, when you connect that, you get this thing that's called a segment. A segment. So, a segment's going to be a part of a circle that's bound by the arc, like yesterday, but instead of being bound by the radius on each side, it's going to be bound by the endpoints of the arc. Okay? Now, how we're going to do this, we don't have like a formula. Yesterday, although we didn't really use the formula as the formula, we just kind of figured it out without the formula. There's not a given formula for how to find the area of a segment. We're going to have to combine some things that we already know how to do. So what we're going to do is we're going to do what we did yesterday. We're going to find the area of a sector. And then if I were to draw this segment, the part that I need is just that outside part. I don't need that inside part. That's not part of this segment. Well, that inside part would be a triangle. I don't have to find the area of a triangle. So what we're going to do is we're going to take the area of the sector, which we learned how to find yesterday, subtract, get rid of the area of the triangle, and whatever's left will be the area of that segment. So sounds pretty simple, but it can be a little tricky at times. But, I mean, it can be fun at times. Okay. So if I try this one, now, before I guess we get started on this one, several of the problems are going to be finding the area of the segment, but some of them are going to involve kind of this idea, but other things, maybe not finding the area of the segment, but maybe finding the area of a different part of the circle. So what we're going to start by doing for each problem is we're going to come up with a game plan. So a game plan, not even worrying about any of the dimensions, any of the angles, anything like that, just by looking at the picture and saying, here's how I'm going to find the area of that shaded portion. Now this one's going to be just what I talked about above. If I wanted to find the area of that shaded portion, I don't have a formula to find the area of a segment, but I do have a formula to find the area of a sector. So we're going to find the area of the sector. And then when I look at that sector, right, which is that whole thing, I don't need the inside part. And the inside part is a triangle. So we're going to subtract the area of the triangle. For these ones, your game plan is pretty simple, but I promise you, if you start with the game plan, it's going to help whenever you get to the end of the problem. So the first thing we need to do is we need to find the area of that sector, just like we did yesterday. So remember from yesterday, to find the area of a sector, you're going to start by finding the area of the entire circle. So we're going to do pi r squared. So my radius is 18. So if I take pi times 18 squared, we should get 324 pi. Now, like I said, though, that's the area of the entire circle. I don't need the area of the entire circle. I just need the area of that little chunk right there. How much of the circle is that sector? 60 degrees out of 306, just like we did yesterday, right? 60 degrees out of 306 degrees, or a sixth. You multiply that together, you're going to get 54 pi. So that's what we did yesterday. I found the area of the sector. But looking at that sector, when I draw the segment, it's split into two parts. It's split into a segment and a triangle. I don't need the triangle. So the next thing we need to do is we need to find the area of the triangle. What I think is going to be really helpful today is draw that triangle. So take it out of the circle and redraw it. okay? I think it will be very helpful to have that to look at and to work with outside of the circle. Now to kind of label the things that I know, this angle, if we're kind of going along with the picture, this angle right here is my 60-degree angle, and it tells me that that side is 18 inches. But if I look at the sides that I have, this segment CB, it's a radius, so the radius is 18 inches. If you look at AC, AC is also a radius. So what is AC? Also 18. So looking at that, what kind of triangle is that going to be? An isosceles. Well, let's look at it even closer. If it's an isosceles triangle, yes, the sides are congruent, but we also learned that the opposite angles are congruent. So these two angles are congruent. So if you have a triangle with one angle is 60, and the other two angles are congruent, or the same, what would those angles have to be? Also 60. So I have a triangle that has 60 degrees, 60 degrees, 60 degrees. What kind of triangle is this? It's an angular equilateral triangle. So all the sides are 18. If you look for those things, it's going to make today a little bit easier. Yes?
Well, all the triangles would be isosceles.
Yes. But not all the triangles will be equilateral. They will always be isosceles because they're always going to be formed by two radii. And the radius is always going to be congruent with the other radius. That's a good question. Okay. Now I need to find the area of this triangle. So to find the area of a triangle, I need the base. At 1/2 the base times the height. I have the base, it's 18. But I need the height. And neither one of these is the height. Because remember, the height needs to go from the top straight down to the bottom. You should see a right angle. What it would look like is it would come straight down here. That's what I need. So, you guys are going to get real excited whenever I get ready to cut it. I took the 60-degree angle, I cut it in half, and it gave me a 30-degree angle. So what kind of triangle do I have? A 30, 60, 90 triangle. Yes, PJ.
One side, the other side of the angle.
You could, if you wanted to. Yeah, that'd be a way. Yeah, you can do that. If you want to. Okay, we're gonna go this way because that's what I've been doing all day. That's where my brain's at. So, okay. Actually, for this one you could, but some of them it's gonna say in simplest radical form. And if it's simplest radical form, then that's going to give you a decimal, so that won't work. So that would be why we want to go this route. So good question, good thought. Okay, so I split that angle in half. I got a 30-degree angle, so I have a 30, 60, 90 triangle. Keep in mind, I need to find this side. Okay, that's my 30-degree angle, which means that's my S. There's a couple ways you can find your S. First, I'm given the hypotenuse. What's the relationship between the hypotenuse and the shorter side? It's half. So if the hypotenuse is 18, what is that shorter side? 9. Another way to think about it, when you split the triangle in half, you're also going to split the 18 in half. Either way. Now I have my shorter side. I need the longer side. How do you go from the shorter side to the longer side? Multiply by the square root of 3. So your height is going to be 9 square roots of 3. Okay, to find the area of a triangle, I need 1/2 the base and the height, which I have. Now be really careful because this got me a couple times whenever I was working out the notes. When I'm finding the 1/2 the base, I'm looking for the area of the entire triangle, not just the half of the triangle I created. I need the whole thing. So when I'm finding the base, I need the entire base. So when I take 1/2, what's the base of the whole triangle? 18. Times the height, which we found is 9 square roots of 3. Remember when you're multiplying with radicals, you only want to multiply the numbers on the outside. So we're going to take half of 18, which is 9. 9 times 9, which is 81. So the area of my triangle is going to be 81 square roots of 3. Now this is where I think you're going to find that it's going to be helpful that we came up with the game plan in advance because we went through all of that work but we don't even have our answer. So instead of having to go back through and remind ourselves how we're going to get our answer, we just go back to our game plan. We're going to take the area of the sector, which we said was 54 pi, minus the area of the triangle, which we said was 81 square roots of 3. Some of your problems today are going to say leave your answer in terms of pi and in simplest radical form. If that was one of these, this is where you would stop. This one says round your answer to the nearest tenth, so you plug this in your calculator, and you should get about 29.3 inches squared. Alright, so we're only going to do 4 of these because they tend to take a little bit of time. The big thing that you're going to do on your homework, you make sure you read the directions. These first ones say round your answer to the nearest tenth. Go ahead and plug it into your calculator. The next section says leave it in simplest radical form and in terms of pi, so you will plug that into your calculator. Okay, number 1. Okay, so we are going to be looking at a segment. So we're going to have a 90-degree sector. Remember, we formed this segment by connecting the endpoints of the arc. And for this one, we want to find the area of that segment. So before I even give you the dimensions, what we're going to talk about that game plan. This is going to be the same as the game plan before and the same as when I talked through your notes, but the next ones aren't going to be quite as straightforward. So I strongly encourage you to do this part, okay? So we talked about the things I have formulas for, the things that I know how to find. I know how to find the area of the entire circle. I know how to find the area of a sector. And I know how to find the area of a triangle. So what we're going to do is we're going to find the area of that sector. But in that sector, I don't need the triangle. So we're going to subtract the area of the triangle. Okay, now to give you the dimensions, the radius is going to be 10 centimeters. Okay, to find the area of the sector, this is just what we did yesterday. I first want to find the area of the entire circle. So we're going to do pi r squared. My radius is 10. So we do 10 times 10. They give me 100 pi. Now remember, that's the whole circle. I don't want the whole circle. I just want that part of the circle. That sector right there. How much of the circle is that sector right there? 90 out of 360, or 1/4. So 1/4 of 100 pi would be 25 pi. Now remember though, that 25 pi is going to be that entire thing. What I don't want the triangle. So next we're going to do is we're going to find the area of the triangle. I strongly encourage you, take that triangle and redraw it. Now me, I like to redraw it so it's kind of oriented nice. So whenever I redraw it, I'm going to do this. And just draw it like that. So just tilt it just a little bit. Now if you notice these things, it's going to be nice, okay? My radius is 10 centimeters. My other radius, we know it's also going to be 10 centimeters. These are the two sides that are making up the right angle. Question for us. Okay, which means I've got an isosceles triangle. And specifically, what kind of triangle? 45, 90 triangle, which actually for this one, I don't really need because I have what I need. Because what I need is I need the area of the triangle. To find the area of a triangle, you're going to do 1/2 the base times the height. This time, I can use this as a height. Because remember, the height has to come from the top straight down. And it does, because it forms a right angle. So to find the area of the triangle, we're going to take 1/2. My base is 10. My height is 10. So 1/2 of 10 is 5. 5 times 10 is 50. So the area of my triangle is 50. Now this is where it's nice having the game plan. Okay, we're going to go back. To find my answer, we're going to take the area of the sector, which we said was 25 pi, minus the area of the triangle, which we found was 50. This time it says round to the nearest tenth, so you plug that in your calculator. Get about 28.5 centimeters. You're going to have 3 or 4 of those. Not too bad. Right? Okay. The next ones we're going to have to approach a little bit differently. Notice the directions on this one. It says leave your answer in terms of pi and in simplest radical form. So we're going to do two that are a little tricky, and then we'll do one that's easier, I promise. Okay? All right, so let's start off with... Okay, so we got this circle here. Let's do a sector that looks like that. And we are going to go ahead and draw this segment. But what we want to find for this one is not the area of the segment. What we want to find in this circle, I want to find the area of everything except the segment. Okay, before I give you the dimensions, we need to come up with a game plan. Now, I'll be honest with you, whenever I went through and did my notes last night, I worked way harder than I needed to because it was kind of where my brain was going, is what I was thinking about, and then whenever I started working out in the second hour, I was like, hold on, there's a much easier way to do that. So let's talk through this. What could be one game plan? Okay, so we can find the area of the whole circle and subtract the area of the segment, which sounds simple. But to find the area of the segment, I'd have to find the area of the sector and the area of the triangle, and I'd have to take the area of the sector minus the area of the triangle to find the area of the segment. Then I would do the area of the circle minus the area of the segment, right? Okay, that's totally doable. That's what I did in my notes. There's an easier way.
The entire circle minus this sector plus the triangle.
So in a way, that's actually kind of the same thing. So that's actually technically what I did in my notes. You can find the area of the entire circle, take out the area of the sector, and then add back in the triangle. But I still have to find the area of the sector and the area of the triangle, which I might have to do anyway. Anybody else see something else I could do? Could I find the area of that? A big sector, right? I could do that. And then could I find the area of that? This would be a 2-step process instead of like a 3 or 4-step process. So let's do that. Let's find the area of the big sector, right? All the way around. Then once I find the area of the big sector, I'm going to add the area of the triangle. And like I said, I did the same thing you guys drew. You look at my notes, I did not do that in my notes. I worked way harder. This is going to be much easier. Okay, now we probably will need some dimensions here. Okay, so this is going to be a 60-degree angle. And the radius is going to be 8 meters. Okay, so the first thing we're going to do is find the area of the big sector. So in order to find the area of the sector, you are going to start with finding the area of the entire circle. So it has a radius of 8. So the area of the entire circle, pi r squared, would be 64 pi. But remember, we're talking about the big sector. We're talking about the major arc, not the minor arc, which is what I'm given. How are we going to find the measure of the major arc? It's going to be 300 over 360. Because we take 360 minus the 60 degrees. It would be 300 over 360. Now, the best way to leave your answer, if you don't do this on your homework, that's fine. The best way to leave your answer is going to end up being a repeating decimal, which means it's technically a fraction. So the best thing to do would be to leave it as a fraction, which some of your calculators can do for you. But as a fraction, it'd be 160 pi over 3. If you turn it into a decimal and round without plugging the pi in there, that's fine, not the end of the world. Best way would be to leave it as a fraction. Okay, so that's the sector. That's the same thing we did yesterday. Okay, now let's talk about the triangle. Like I mentioned, what I would do is I would take that triangle, go ahead and just write it out off to the side. I just kind of tilted it a little bit. So if that's my 60-degree angle, like we did on the last two, the sides that surround the 60-degree angle are both radii, which means they're going to be 8 and 8, which means it's an isosceles triangle, which means these other two angles are congruent, like the first one we did. What kind of triangle is this? This is an equiangular, because they're all going to be 60, which means it's also an equilateral. So I need to find the area of this triangle, so we're going to do 1/2 the base, which I have, times the height, which I don't. Now the height that I'm looking for, it's that longer side. Okay, it's the side opposite the 60-degree side. What I need is I need the shorter side. Like we did on the first one, there's two ways to find the shorter side. Probably the easiest, you took that base and cut it in half. So what is the shorter side? 4. You could also take the hypotenuse and divide it by 2. Either way, my shorter side is 4. What is my longer side? 4 square roots of 3. So I have my base, I have my height. To find the area, we will take 1/2. My base, remember you have to take the whole base. I know we cut the triangle in half, but we're looking for the area of the whole triangle. So we're going to take 1/2 times 8. My height is 4 square roots of 3. Remember with radicals, you're just multiplying the numbers on the outside. So half of 8 is 4. 4 times 4 is 16 square roots of 3. Okay, so this is where I really think coming up with that game plan helps, because we went through all of that work, our brains are just about done, and then you have to go back and remind yourself, what am I supposed to do with these numbers? We wrote it down, right? You're going to take the area of the big sector, which we said was 160 pi over 3. We're going to add the area of the triangle, which is 16 square roots of 3. Now this one says leave it in terms of pi and in simplest radical form, so you would leave your answer like this, but make sure you throw on your units. Yes, Amy?
Why does the pi only go to the 160 with the 2?
The 3's in the denominator, right? Pi, if I have pi just by itself, technically I could write it as pi over 1. So if you multiplied 160 over 3 times pi over 1, those would go together. And you don't necessarily have to put the pi in the numerator. That's probably the best way to write your answer. But if you just wrote the pi like off to the side, that would mean the same thing. That'd be fine. Okay, let's do one more like that. That takes a little bit of effort, and then we'll do one that's a little bit easier. Okay, number 3. We're going to do kind of the same idea, except we're going to be looking at a bigger sector here. We're still going to draw this segment. And just like the last one, we want to find the area of the entire circle except for that segment. Kind of like the last one, there are other ways to do this, but I think probably the simplest way, I kind of have two pieces that I'm looking for the area of. I'm looking for the area of this big sector here, which I know how to find. So if I find the area of the big sector, the only piece I'm missing is that triangle. So then we are going to add the area of the triangle, similar to the last one. Okay, this measure right here is going to be 120 degrees, and the radius is going to be 30 inches. So to find the area of the big sector, we're going to start with the area of the entire circle, so pi r squared. R squared, 30 squared, 30 times 30 would give me 900 pi. But remember, I'm not talking about the whole circle. And be careful, I'm talking about this major arc, right? The sector bound by that major arc there. So I need the measure of the major arc. How are you going to find the measure of that major arc?
369 500.
Minus what?
Sorry, minus 120.
Very good. 360 all the way around. Minus 120, that
I'm
angle
tired.
right there. I get it, me too. Okay, so we get 240 out of the entire 360. Multiply all that together, you should get 600 pi. So that would be that part of the circle. Now I just need the area of the triangle. So, like I said, this is totally not necessary, but it just kind of makes me feel a little bit better, I think. I like to sit on its nice, that big flat side, so I'm just going to draw this triangle like this. Don't have to. Like I said, it just makes me feel a little bit better. So this top angle here, I'm just kind of flipping it all the way around. It's going to be your 120-degree angle, which means the two sides, they're both a radius. The sides that make up that 120-degree angle are going to be 30. Now to find the area of a triangle, we need the base, which I don't have, and the height, which I also don't have, but they're pretty easy to find once you find the other. So the height would be this distance here. So I'm taking that 120-degree angle, cutting it in half. So it's a 60-degree angle. So pay close attention here, because my 60-degree angle is at the top, which means my 30-degree angle is that bottom right-hand one, which means my shorter side is the height. So the easiest way to get the height, or the shorter side, is to look at the hypotenuse, because the hypotenuse is twice the height. So what's my height? 15. And that other longer side, 15 square roots of 3. Now remember though, I'm going to want the entire base, not just half of the base. So if this is 15 square roots of 3, that other side is also 15 square roots of 3. So the whole base would be what? 30 square roots of 3. Okay, so to find the area of the triangle, we're going to take 1/2. We said the base is 30 square roots of 3 times the height, which is 15. Okay, half of 30 is 15. 15 times 15 would give me 225 square roots of 3. Okay, we're going to go back to our game plan. We said we're going to take the area of the big sector, which is 600 pi, add the area of the triangle, which is 225 square roots of 3, and we're going to throw the inches squared on there at the end. Okay, you're going to have a few that are that fun, and then you'll have a few that are a little bit easier. Okay, so let's do just one that's going to be a little bit, maybe not simpler, but definitely a little easier. Okay, number 4, last one. Okay, so you're just going to have to kind of pay attention when we're going through drawing this. Draw a figure that looks kind of like this. Now, when you get to your homework, some of the diagrams are going to have circles, but they're not going to be complete circles. How you're going to know that it's a circle and not half of like some weird figure is you're going to see a dot. If you see a dot and then something that looks like a circle, it means that's the center of the circle. You can assume that that is that much of a circle, okay? And we'll do that on all 4 corners. So we're going to have this circle. That can be a great diagram on all 4 corners. So once again, those dots, wherever you see those dots, that represents the center of that circle, even if it's not the whole entire circle. Now for this one, what we're trying to find the area of that part in between there. Okay, we're also going to have that all of these little segments here are congruent. All right, so we need a game plan. What's that big, the outside figure? A square. Does it look like a square, or do you know for certain it's a square? How do you know for certain it's a square? All sides are congruent. Okay, so it is going to be a square. Okay? Anybody have a game plan? Okay, we're going to take the area of the whole square And what we're going to do is we're going to subtract all of these. Okay, these are parts of a circle. How much of a circle is like that part right there? It's a fourth of a circle. How much is that part of the circle? A fourth. And that? A fourth. And that one? So I have 4/4 of a circle. That's a whole circle! Right? So we're going to find the area of the square, and we're going to subtract the area of one entire circle. Let's split it into 4 parts. Okay? Make sense? Okay. And the information we're going to be given, one side of the square is 14 inches. So the whole side is 14 inches. So how do you find the area of the square? Length times width. 14 times 14 would give me 196. That was easy. Then I need to find the area of the circle. Because remember, it's like one circle, but like broke it up into 4 parts. So if I just look at one of these, find the area of the circle, I need pi r squared. What's the radius? 7. Right? Because all the way across is 14. Halfway across would be 7. So pi r squared would be pi times 7 squared, which would be 49 pi. Subtract those and throw your units at the end.